Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Now we are going to present our production for pil Lajakkruih type A. Group member for this presentation will be me, Aida Syahida Junaidi, Muhammad Fairudi, and Zulkifli. For this introduction, we are in charge for monitoring the quality of tablet production from Lajakkruih that produce health supplement diet tablets called Lajakkruih type A. We will perform a statistical analysis for data set 200 samples. The observation taken random at 3 production shift run daily, which is morning, evening, night in December 2020. From the data given, we have calculated and analyzed the data using Microsoft Excel. I have summarized the data of Lajakkruih tablet and divide by 3 groups, which is weight, relative density, and tensile strength. Also, here we divide by 3 characteristics, which is morning, evening, and night. What we got from the data summarization is weight for morning 23401.13, weight for evening 26949.87, and also weight for night 19593.2, and the total for all weight for shift is 23314.71667, and we will do the same thing for relative density and also the tensile strength. For the total of sample, we will count by each shift, morning, evening, and night, and total up with 200 for all samples. From the data that we have rearranged earlier, we can calculate the sum of weight, sum of relative density, and also sum of tensile strength for every shift, evening, morning, and night. Also, we can get the grand total for each weight, relative density, and also tensile strength. Through the sum chart, we can observe that which shift have the higher of weight. We can summarize that the night shift have the lowest data compared to morning shift and evening shift.
On part B of our assignment on statistics, part B and part C. So we begin with part B. Part B is the question was comment on whether there is a significant evidence that the tablet produced in December 2020, regardless of shift, do follow the distribution, which is distribution as stated in our H0. The data follow normal distribution with mean 350 and standard deviation of 14. Alternatively, H1, the data does not follow the normal distribution with mean 350 and standard deviation of 14. So from the sample, we're going to tabulate all the weight distribution, and then we're going to put it in this table, and from this table, we're going to group it, and from the range here, we're going to come out with this count of shift. This count of shift is how many times the weight coming out from this range. So we have 200 samples, so total up of this frequency will be 200. So from this table, we're going to extract the data and put this in our test statistic table. X is the weight range from 310 until more than 380. So we're going to group it each to 7 categories. So in this column, the OI is the observed value. So from here, we're gonna, from this observed value here, this probability, if we sum up all the probability of this weight on all the weight, it will become 1. Here is the expected value. The expected value, we get the expected value by multiplying the frequencies, the sample, 200 sample, against its probability. And once each probability is obtained, if we sum it up, it will come back to 200 again. Here, the last column is our chi-square test. Chi-square test we obtain by observed value minus the expected value square divided by expected value. So when we do the calculation, we're gonna come up with this figure, all this figure, and then we're gonna total up this all this figure, and then we come up with this value. This value we will compare it to our chi-square distribution table, where how we're gonna find it. Our chi-square distribution table is by x square k, which is the how many category we have here, is 7. Why we say 7? Because here I already group it into 1, 2, 3, 4, 5, 6, 7. So 7 minus 1. Our alpha is 0.05. So we're gonna see this. We're gonna find this inside our chi-square distribution table. So from the table, we're gonna come up with this figure, 14.0671. So we already have the chi-square test result and the number from the chi-square distribution table. So since chi-square test is much lower than the chi-square distribution that we got from the table, hence we can conclude that we failed to reject this norm, meaning to say the data is following the normal distribution of 350 means and standard deviation of 40 milligram. Now we move on into part C. Part C is the question is whether there is any significant difference between the tablet weight from different shift. So how we gonna find the solution for this? We're gonna use one-way ANOVA. So from here we're gonna tabulate all this shift. We're gonna separate into 3 shifts: evening, morning, and night. From here we're gonna get all this count, how many, and sum, and the average, and the variance. So SS is the sum of square, DF is degree of freedom, MS is the mean of square, and F value is the ratio of this over this, and then the F critical value is the upper critical, as we assume the alpha is 0.05. So from our hypothesis, H0 is, we assume that there is no different weight, there is no significant weight distribution between different shifts. Alternatively, for H1, there is a significant weight between the shift. There is significant weight of tablet between the shift. So from the one-way ANOVA, we can conclude that for the F test value is 0.05, is smaller than the F critical value. So we can conclude that we fail to reject H0, meaning to say we accept it. We accept that there is no significant difference of weight tablet between the shift. Alternatively, we can use the p-value. Since p-value is more than 0.05, thus we fail to reject H null and we can conclude that there is no difference exists in weight. This is the last part for our presentation by our group, that is need to prediction of the tensile strength for such tablets, and also to comment the validity of the model that you have used to carry out this prediction.
Linear regression model by predicting on the tensile strength and relative density of Lajakkruih for tablets based on December 2020 data. Studies have shown that there is relationship between the tensile strength of the tablet and relative density regardless of three shifts. There was morning, evening and night shift. The tensile strength is dependent variable and the relative density is the independent variable. Here is the type of relationship graph. One is linear relationship, positive linear relationship and negative linear relationship graph. The second one is non-linear relationship and no relationship graph.
The linearity result of the test concluded 95% confidence in linear relationship between tensile strength and relative density, and that will give the valid data result of this tablet. The equation to describe this relationship is y equals to mx plus c, which is y equals to tensile strength, m equals to slope, x equals to relative density values, and c equals to intercept.
Here is the Excel analysis model to estimate linear equation coefficient as shown below. We have that coefficient, standard error, t-statement, p-value lower 95% and upper 95%, lower 95% and upper 95%. The linear regression equation is obtained as shown. Independent variable was x, dependent variable was y, and also the low relative density that the equation needed is at 68%, 74.3% and 80.1%. Here is the chart comparison. The blue dot means that the tensile strength provided from the question, and the orange dot means that the predicted tensile strength data. Here is the estimation errors. The tensile strength should be 0 when relative density is 0. The reason why it becomes like that, when relative density equal to density of tablets or pills divided by density of reference materials and time 100%, and density equal to mass of pills or mass of tablets divided by volume of tablets. The tensile strength should be 0 when no test was carried out. Here is the predicted tensile strength data from linear regression equation. As we know, the question given the low relative density 68%, 74.3% and 80.1%. Here is the example method of a calculation using low relative density that given relative density of 68%, y equals to 5.559209 megapascal, and if the interception equals to 0, y equals to 5.3788 megapascal. Here is the predicted tensile strength range of the pill with 95% confidence. The range is for 68% between 5.3788 to 5.559209, 74.3%, 5.87713, 6.5780602, and 80.1%, 6.33591 to 6.5169358.
Here, I can conclude that the conclusion for part A, we can analyze data using Microsoft Excel CAM with pivot table field. The formula creates the chart clearly with the input of production. It's easy to compile all the data for productions. At the last part, linear regression model is a valid model to predict the test results of the tensile strength of the pill. It's because the standard error for this model is 0.096864 based on the statistical analysis, and from the data analysis also we're using 95% accuracy level. That was enough to see the validity of the model. So that's all from our group for the presentation. Thank you very much for the attention, and have a nice day. Bye.